This is the prep packet video for Unit 4, Chapter 9.5, Objective number 2. And in this objective, we're working on simplifying before we add and subtract. So sometimes it looks like two radicals cannot be added or subtracted. But if the radicals can be simplified, then they turn out to be like, then you can add or subtract them. So it's one of these things that sometimes the radical is hiding, and I'm going to have you look at some examples. Here, at first glance, let's see, I've got the square root of 2, the square root of 50, and the square root of 45. Superficially, they are not the same, but we might be able to take some stuff apart using the product rule and see what we've got. So the first one, that's going to stay the way it is because the square root of 2 is as small as it's going to get. But here, this could be 3 times the, let's see, 5 squared times 2, because 25 times 2 is 50. And here I have, let's see, 45 is the same as 9 times 5, and that's the same as 3 squared times 5. So once I have that, again, like I said, this first one's going to stay the same, but this, because this is squared, the 5 can come out. So I'll have 3 times 5 times the square root of 2. And here, that can come out, so I'll have 3 times the square root of 5. So let me write it with better handwriting. And now I get to look for like terms. And here I have the square root of 2 and the square root of 2 and the square root of 5. So 5 doesn't belong. It's like Sesame Street. One of these things is not like the other. But the ones that are like, we're going to combine. So 8 plus 5 is 23 root 2 minus 3 root 5. And what we've done here is we've simplified this expression. So let's take a look at this. And again, at first glance, the cube root of 40 and the cube root of 5 have nothing to do with each other. But 40 has the factors of 8 and 5, right? And 8 is the same as the cube root of 3. And I'm going to admit, because I saw that the 3 in the index, I thought, well, what's in 40 that's a cube root? And I had good background knowledge that 8 was hiding in there. So I'm going to rewrite this, negative 7 root cube root 2 cubed times the cube root of 5 plus, and we're just going to leave this because there's no coefficient and it won't get any smaller. So let's see, that's going to be negative 7. The cube root of 2 cubed is 2. So negative 7 times 2 is negative 14. Cube root 5 plus cube root 5 would give me negative 13 cube root 5. And as you see, I have simplified. There's no equal sign, so I'm not solving for anything. I'm just trying to get things down to lowest terms. So let's take a look at this. I have 10 root 8t minus 9 root 2t. Well, let's see what we've got in there. I've got this is as simplified as it's going to get. This is the same as the square root of 4 times the square root of 2t, right? So I'm going to rewrite the whole thing. 10. Actually, I'm not going to rewrite it. I'm going to do one more thing before I do. What's the square root of 2? Or 4? Oh, I gave it away. It's 2. So now I have 10 times 2 times the square root of 4t. Oops, I'm not paying very good attention here. 10 times 2 times the square root of 2t. This is the one that comes down. Minus 9 times the square root of 2t. Again, now I have like stuff going. So that's 10 times 2 is 20. 20 minus 9 is 11. Let's do this one. So here I've got x and I have, oh goodness, there's a lot going on here that has to be simplified before we can even attack. At first glance, I know I can't combine it. I have to simplify first. So here I have, let's see, this is going to stay, but this 3 roots, so that's the cube root of x times the cube root of y to the 6th plus the cube root of x to the 7th. This is super simplified. I'm going to leave it alone. This one, 3 goes into 6 2 times, so y to the 2nd comes out, leaving behind nothing. And this comes down. And then here, I can simplify this because 3 goes into 7 2 times with 1 left over. And all of a sudden, all of a sudden I have like terms, right? Look, there's one and there's one. So I'm going to rewrite this. Oh, I could actually take out that as a factor. So I'll have y squared plus x squared times the cube root of x. Because x, if I distributed that, it would go that, and then it would go that. So there you go. And that's as far as we can go with this. But it tells us a lot more than we had to begin with. Here's a few more examples. Here I have the same index. That's a good sign. And I am going to check and see whether 96 is divisible by 6. Let's see, 9 and 6 is 15. And 1 plus 5 equals 6. So it is divisible by 6. 96 goes into 6 16 times. And so I'll have the 4th root of 6 plus the 4th root of 6 times the 4th root of 16. The 4th root of 16 is 2, because 2 to the 4th equals 16. So I have fourth root of 6 plus 16, sorry, 2, because remember, 2 4th root 6. And that's the same as a secret 1, right? So 1 plus 2 is 3 4th root 6. Because remember, we're treating this chunk and this chunk as if they were variables. Here, let's see, let's do some factoring first because they're not the same. So I have the cube root of x cubed times the cube root of y plus the cube root of y. Their common factor is the cube root of y, so I'm going to pull that out. And what's left behind? Well, the cube root of x cubed is 1, or sorry, x, and if I take the factor out that, then I leave behind 1. So let's double check it and make sure I did it right. 3 cube root of y times x would be x cube root y. That times 1 would be, and that's what I would have ended up both up here. Okay, good. So here, again, we're going to do some factoring because this is the same as 4 cube root, or square root 25 times square root of 2n minus 6 square root 2n. That's the same as 5, so 4 times 5 is 20 root 2n minus 6 root 2n. 20 minus 6 is 14. And again, these are just chunks that I'm handling them just like I would a variable. So I want you to have more practice on this because it just takes a little bit to sort of get your brain to relax. I want you to do you try problems on 556 and be sure to include the work with your prep packet. That's it for now.